Ladies and gentlemen, thank you for watching this Hanson Math video on polynomial division. In specific, this video will cover dividing a polynomial by a monomial and long division of polynomials. And off we go. First, we're going to tackle division by a monomial. This is where the divisor is just one term. Here is the divisor. The numerator is the dividend, and the answer is the quotient. Now, this is very much like simplifying, and a good way to tackle this is just splitting up the dividend into pieces using the divisor, in this case of 3x. So, what I'm going to do is I'm going to rewrite my 12x squared y, and I'm going to divide that by my denominator of 3x, and plus my other term in the numerator, 3x, that also gets divided by the divisor, 3x. Okay, so you always may split it up like that, splitting up all the terms in the numerator by the denominator. Now you simplify. 3 goes into 12, 4. This x cancels into this x, dropping down to the power to 1, so that's just plain x. And then you still have your y. Plus 3x divided by itself, well, anything divided by itself is 1 whole. So that one is completed. Again, dividing by a monomial is pretty much just simplifying. We'll look at one more example. In this time, we have a trinomial divided by a monomial of xy. So again, we'll split it up into the 3 different pieces in this case. We have 6xy squared divided by xy minus 3xy divided by xy plus 2x squared y divided by xy. Now it's just a matter of simplifying. We have this 6 here and no constant below to divide out, so we have 6. X cancels with x, that's gone. And this y drops y squared down to just y to the first. So we have 6y minus 3. X on top, x on bottom, cancel. Y on top, y on bottom, cancel. Plus 2. This x on bottom cancels. It goes into x squared, dropping a power down to 1. So that's 2x. And y divided by y cancel. So here you have it. If you like to change it into x, y, and then constant, you could rewrite it as 2x plus 6y minus 3. Final answer. Okay, again, dividing by a monomial is not too difficult. It's just splitting up the denominator, which is the divisor, amongst the terms in the numerator, and simplifying. The next topic we're going to look at here is turning back time to old school long division, maybe from 3rd grade or 4th grade. And a lot of teachers skip long division of polynomials. I like to do it because it can come in handy when you're looking for roots and zeros of polynomials. So before we go any further, I like to do an analogy to old school division. So let's take a walk back down memory lane, shall we? Alright, first we're going to look at 51 here, which is our divisor. The dividend is 7,286, and we need to say 51 goes into 72 how many times? Well, it can go in there, fit in there once. It can't go twice because you're going to be at 102, which exceeds 72. So 51 fits into 72 one time, and then you multiply back. 1 times 51 is 51, and if you remember, you subtract. 72 minus 51 is 21. You bring down the next place value, which is the 8, and you ask yourself, 51 goes into 218 how many times? Well, it'll go 4, and then you multiply back. 4 times 51 is 204. You subtract that. 218 minus 204 is 14, and then you bring down the 6, 146 goes into 51. Let's see, 3 would be 153. That's too much, so only can go in there 2. 2 times 51 is 102. So if we subtract that, we're left with 44. That's a remainder. Keeping in mind, you can express a remainder as a fraction over the divisor. So it's 44 over 51. So the answer here is 7,286 divided by 51. The answer, the quotient, is 142 and 44/51. That's old school division with a remainder, which can be expressed as a fraction. Now the reason I do this is, to me, long division of polynomials is very analogous to this. It's not that much different. It's a very likewise process, as you will see. And we'll get right to it. But first, a quick review. See, I threw you a curveball. Let's FOIL out or multiply x minus 2 times x plus 5. Now, there's a method to my madness here. Okay, doing that first, x times x, x squared. Outside, 5 times x is 5x. Inside, negative 2 times 5 is negative 2x. And last, negative 2 times 5 is negative 10. Simplifying the outside and inside here, we have x squared plus 3x minus 10. Okay, why did I do that? Well, I'll explain why. If you take either of these two factors that we've just multiplied together and you divide either one of them into this quotient, this answer, you must get the other one. So in other words, if I take x squared plus 3x minus 10 and divide by, say, x plus 5, the answer must be x minus 2, because that is how the division works. So let's try it here and see what happens. So let's divide by x plus 5. And what are we going to divide? We're going to divide that answer we just got, which is x squared plus 3x minus 10. And then thinking mathematically, we already know the answer. We're going to have to get this x minus 2. If we don't, something has gone awry. Okay? So basically, this is how this works. I start with my x right here, and I compare it to this x squared. And I ask myself, x times what gives me x squared? Well, it's x times x, so I need to multiply by x. This is the x column, so I put the x up here, and I multiply back. X times x is x squared, and x times plus 5 is positive 5x. Just like old school long division, you subtract. X squared minus x squared, gone. That's good. You want those to cancel. 3x, take away bigger 5x, you're into the negatives by 2x. Bring down the minus 10. Now, you ask yourself, you go back to this first position here. X times what gives me negative 2 of x? Well, that's minus 2, which goes up here in the constant column. Multiply back. Negative 2 times x is negative 2x, and negative 2 times 5 is minus 10. Now, when you subtract, anything subtracted by itself is 0, so you have 0 remainder, and you got what I said you'd get. You got your x minus 2 factor. Now, maybe I just blew you away, and that was, you got the Krispy Kreme look. Your eyes got glazed over. That's okay. We're going to do several more examples. So hang on to your hat, this will make sense, you just have to practice it. You might want to hit pause and get out paper and pencil and do this with me, or you can watch and do the next couple examples. Make this video your own. Here we have a trinomial. We have c squared minus c minus 30 divided by c minus 6. So what we're going to do is c minus 6 is the divisor, and the dividend is the numerator, c squared minus c minus 30. So again, it's all about starting with this lead-off variable right here, and you ask yourself, c times what gives me c squared? Well, that's c times c, so that c lines up in the single power column. Now you multiply back, just like you would for long division, which this is. C times c is c squared, and c times minus 6 is negative 6c. Okay, draw your line, subtract. C squared minus c squared gone. That's good. If those don't cancel, you made a mistake. Negative c minus a negative. Minusing a negative is add the opposite. So now effectively we have a negative c plus 6c, which is 5c. Bring down the minus 30. Now you ask yourself, c times what gives me 5 of c? Well, that's a positive 5. Multiply back. 5 times c, 5c, 5 times negative 6, minus 30. Subtract. Anything subtracted to itself is 0, no remainder. There's your answer, c plus 5. How could you check this? FOIL c plus 5 times c minus 6, and you must get the numerator. If you don't, you made a mistake. This is self-checking. Okay, a couple more examples if you're willing. If not, you could check out here at any time. Here we've got a 4-term polynomial divided by a binomial. So let's get right to it. We have 2x minus 1 all divided by 4x to the 4th minus, notice there is no third power term, so we're going to leave a placeholder here. There is no third power, so we have 0 of x cubed minus 5x squared plus 2x plus 4. That's very important. It helps keep your place value. Okay? If you're missing any variable power in descending order, you need to put it in as a 0 quantity. Very important. Okay. Start here and ask yourself, 2x times what gets me back to 4x to the 4th? Well, I need a 2 and I need x to the 3rd, so that goes in this column with the x to the 3rd, 2x to the 3rd. Multiply back. 2x cubed times 2x is 4x to the 4th. These must match. If they don't, you messed up. 2x cubed times negative 1, negative 2x cubed. Subtract. 4x to the 4th minus 4x to the 4th, gone. Nothing, subtract the negative, which is add a positive. So we have 2x cubed. Always bring down the next term, which is negative 5x squared. And you ask yourself the question, 2x times what gives you 2x cubed? Well, you already got the 2. To get x to go to x cubed, you need a positive x squared. Multiply back. X squared times 2x is 2x cubed. Again, these have to match. If they don't, something went wrong. And x squared times minus 1 is negative x squared. Remember, it's always subtracting. 2x cubed minus 2x cubed, gone. That's what needs to happen. Add the opposite. Negative 5x squared plus x squared, negative 4x squared. Bring down the next term, which is a positive 2x. Go back here. 2x times what gives me negative 4x squared? Well, to get the negative 4, we need to multiply by a minus 2. And to get plain x to the second power, we need another x. Multiply back. Negative 2 times 2x is negative 4x squared. And negative 2x times negative 1 is positive 2x. Subtract. Negative 4x squared minus a negative 4x squared, gone. 2x minus 2x, 0. Bring down the 4. Okay? 2x times what will give me 4? Well, you can't do that because you're not comparing like powers. So at this point, since there's nothing left to bring down, 4 is your remainder. So again, much like old school division, to express your remainder, what you do is you add the remainder 4 as a fraction over the divisor, which is 2x minus 1. Okay? I know this can be very challenging for students. Let's do one final example and then this video will be finished. Last example. In my last example here, I specifically chose this so that you'll get some help and some practice with using the placeholders for the powers that don't appear in the dividend. So here we have y to the 5th, and then we have y to the 2nd, and then we have a constant. So you're missing some powers of y. So watch this. Here is our divisor, y minus 2. And we're dividing by y to the 5th. There is no 4th power here, so we keep a placeholder for it, 0y to the 4th. There is no 3rd power, so we keep a placeholder for that, 0y to the 3rd. We do have a squared term, that's minus 3y squared. There is no linear or 1st power term, so that's plus 0y. And we do have a constant, minus 20. Okay, although this is long, it's the same process. So here we go. Let's take a look at our first term here compared to this guy. Y times what gives you y to the 5th? Well, that would be y to the 4th. So that goes in the y to the 4th column, and you multiply back. Y to the 4th times y is y to the 5th, and y to the 4th times minus 2 is negative 2 y to the 4th. Subtract y to the 5th minus y to the 5th, gone. 0 minus minus is positive 2y to the 4th. Bring down the next term, which is plus 0y cubed. Ask yourself the question, y times what is 2y to the 4th? Well, you need 2y cubed. Notice how it lines up nicely. Multiply back, and you get 2y to the 4th minus 4y to the 3rd. Subtract that. These must cancel, and they do. You have nothing minus a minus, which is positive 4y cubed. Bring down the next term, which is negative 3y squared. Ask yourself the question, y times what is 4y cubed? So you need positive 4y squared. Notice how nicely that lines up. Multiply back. 4y squared times y is 4y cubed, and 4y squared times minus 2 is negative 8y squared. Subtract. 4y cubed minus 4y cubed, gone, which has to happen. Now subtracting a negative is adding the opposite, so you have a negative 3y squared plus 8y squared is 5y squared. Bring down the next term, which is plus 0y. Ask yourself the question, y times what is 5y squared? That would be 5y. Multiply back, you get 5y squared, and 5y times negative 2 is negative 10y. Subtract. 5y squared minus 5y squared, gone. 0 minus a negative, that's plus 10y. Finally, bring down the minus 20. Ask yourself, y times what is 10y? That's positive 10. Multiply back. 10 times y is 10y, and 10 times negative 2 is minus 20. Anything minus itself is 0, so we have no remainder. There is your final answer. Again, feel free to review these examples. This is how you do long division of polynomials. Thank you very much for hanging in there, and I hope you learn a little bit about dividing polynomials. I'll catch you later.